Hey everybody, Ms. Dietrich here. We're taking a look at lesson 7.5 on evaluate algebraic expressions and formulas. The essential question that we're going to be answering is, how do you evaluate an algebraic expression or a formula? To evaluate an algebraic expression, substitute numbers for the variables and then follow the order of operations. Let's come back to this problem. But first, let's make sure we know about the two kinds of expressions. So earlier, we learned about the idea of a numerical expression. And if you were to ask yourself, what do they include numbers, and they also include operations. So today, we're talking about algebraic expressions. So they also will include numbers and operations. But can you think of what that third thing is that's going to be unique to algebraic expressions? Well, it's going to be numbers. Going to be operations. That third thing will be variables. And recall that a variable is a letter that holds the place for some value. All right, so if we take a look at some of these examples and ask ourselves, are they algebraic or not algebraic, which means they might be a numeric expression. This one has a variable in it, so that would be algebraic. This one has a variable in it, so therefore it would be algebraic. These are all numeric values. I don't see any variables there. So that would be non-algebraic, or we actually would refer to that as a numeric expression. Let's look at the right side. Here we have a variable of y. So given that fact, that makes that algebraic. Here we have all numbers, all numeric values. So that would be not algebraic. And here we have a bunch of variables. So again, that's algebraic. All right, so now that we're clear on the difference between algebraic and not algebraic, also called numeric, let's take a look at the example. This example right here. Mitchell is saving money to buy an MP3 player that costs $120. He starts with $25, and each week he saves $9. The expression 25 plus 9W gives the amount of dollars that Mitchell will have saved after W weeks. So we're trying to figure out how much will Mitchell have saved after 8 weeks. So first of all, we're going to evaluate our expression here for W equals 8. But how do we come up with this idea of the expression itself, the 25 plus 9W? We have to ask ourselves, which operation does the expression 25 plus 9W include? And it includes multiplication and addition. So again, here's the addition, here's the multiplication. In what order should you perform the operations? Well, we always multiply first and then we add. So if we're going to multiply first, that means we're going to substitute in the value for 8 in the place of W. So that really means that we're going to be doing 9 times 8. We would multiply those two things first, just because order of operations says that we do that always, even if the directions don't remind you to follow order of operations. We get the 72, and then add these two values and get the 97. So we know that Mitchell will have saved $97 after 8 weeks. After how many weeks will Mitchell have saved enough money to buy the MP3 player? So if we were asked to make a table to find the week when the amount saved is at least $120, we could look at week 9, substitute in that value into the formula, because here's the expression rather up here. And if we substitute in the 9 and actually multiply the 9 times 9 first, we get the 181, and that would be $106 saved. What if we plug in 10 into the expression? We would have to do the 9 times 10 first, which would give us the 90, and then add the 25, which would be $115. So remember, we want to get to $120. So let's see if week 11 is going to do it. We would multiply the 9 times 11 first, which would give you the 99, and then add the 25 to the 99 and you have enough money. So that's enough, right? Because we need 120. We have more than that, which means we're going to be in good shape after 11 weeks. All right, so what if we have to explain this? Explain what it means to substitute a value for a variable. You're just taking whatever this stands for. So in this case, we're talking about weeks, substitute it in, and then apply it to the rest of the numeric values and do the operation. All right, so let's move on to another example. Let's look at this example, shall we? Evaluate the expression for the given value of the variable. Now, the one thing I don't like about how the Go Math presents it is I almost would like to see like more space. I almost like to see this kind of separated out a little bit. It seems like it's pushed up next to it. So at first glance, you might look at that and say it's you're solving an equation, but it's not. It's an expression. So we always write the expression first. Once you have the expression written in there, then you go back and look, what are you supposed to substitute in for the letter M? And that value is 14. So we're going to substitute in a 14, and this will become 14 minus 8. So that's first, substitute in the value. The next thing you do is, of course, you're going to perform order of operations. You're going to look for what are those things you're going to do first. So we would do what's in the parentheses first. And if we subtract the 14 minus 8, we would get 6. And then you want to write everything else that's left. Then you ask yourself, when we follow order of operations, what would we do next? If we have both multiply and divide, then you do whatever comes first from left to right out of those two. So that would be the 4 times 6 that we would do next. And I like to box it in as I do it. 4 times 6, which would give us 24. We bring down the divide by 3, and then we finish it up and do the 24 divided by 3 and get the 8. So again, the key is just simply substituting in the value in the place of the variable, and then proceeding with simplifying the expression, which would then be numeric at that point. All right, let's look at another example. What if we had to evaluate this expression for y equals 4? So what I always like to do is I like to rewrite everything. So I'm going to rewrite the 3, the times, and then instead of putting the y, I'm going to put in the 4. I'm substituting in the 4. So let's put that in. But you don't want to forget about this exponent. And then we have to put in plus 2. All right, and let's just remind ourselves about order of operations. So we're using that statement, please excuse my dear Aunt Sally, but we're not writing it across like I see some teachers do. I like to write it in this kind of hopscotch pattern. So we do have parentheses. We're going to do that. We're going to do the stuff in the parentheses. So this and this are parentheses. Now, there are two operations within the parentheses. We have an exponent and we have addition. So we have to follow the order of operations within the parentheses. That means we're going to do the exponent before we do the add, which means this is next, 4 squared. 4 squared is not 8. It's not 4 times 2. It's 4 times 4. 4 is a factor twice. So if we complete that, we get 16. Now, once you figure out what's in the green box, then it's time to rewrite everything else. Even though we don't like it, it gives us hand cramps. All right, but we have to keep that parenthesis. All right, and now next, we're not finished with the parentheses because we still have an operation here. We still have to add, do the 16 plus 2, and get 18. And now we can drop the parentheses because we've done everything inside it. And we know that we're going to be multiplying that result with 3. Now, if you can't do that in your head, which we wouldn't expect you to, then off to the side, you do the algorithm for 18 times 3. We get the 24 here. 3 times 1 plus the 2 more would be 5. So we get the 54 as our final answer for that. All right, so let's take a look at another example. The formula perimeter equals 2 times the length plus 2 times the width gives the perimeter P of a rectangle with a length of L and a width of W. What is the perimeter of a rectangular vegetable garden with a length of 2.4 meters and a width of 1.2 meters? So step 1 is to rewrite the formula. So I'm going to write that down. P equals 2L plus 2W. And now let's substitute in the values. So for the length, I'm just going to put a set of parentheses there. And I'm going to put a set of parentheses for the W. And let's go back and look to see. So for the length, they're telling us right here, length of 2.4. So where you see the L, we're going to stick the 2 4/10 in there. All right, and then where we see width is this. We're going to substitute in the 1 2/10 for the W. All right, so this means we're multiplying these two things together. This means we're multiplying these two things together. Now remember, we have to multiply before we add. So we're going to come up with this number, put it here. We'll come up with this number, we'll put it here, and then we'll add those two values together. So that's going to require doing the algorithm. So when we look at how do you multiply this, I usually like to put the value that has more digits as the top factor, and then we'll put the 2 on the bottom. All right, so here we get the 8. This is 4. And we have to go over 1 with the decimal, go over 1. So we're looking at 4 8/10. This times this is 4 8/10. All right, for this, same deal. Let's take the factor that has more digits and we'll put that on top. Here we get the 4. Here we get the 2. 2 times 1 is 2. And again, we have to go over 1 place value, go 1 to the left. So that becomes 2 4/10. All right, so we have to add these two things now. We have to add 4 8/10 and 2 4/10. Since I already have that written there, I'm just going to write the 4 8/10 under here. And we're going to add these two things together. So again, we're adding this number and this number together. So 8 plus 4 gives you the 12. And then here we have 1 plus 3 plus 4. So that's going to give you 7. And then we have to bring the decimal down. When we're adding, recall, we bring the decimal down. We don't move it over. All right, so we're looking at this plus this, and we got 7 2/10 as our perimeter. So we're going to bring the p down. Perimeter equals 7 2/10. All right, so that one's all done. All right, let's look at something like this. Evaluate 5k plus 6, 4, k equals 6. Step 1, you write the expression. Step 2, you substitute in the 4, because that's what it says right here. They're telling you k is equal to 4. So we substitute that in. We realize that we have to do this next, right? We have to multiply because order of operations says that we always do that. And I always like to kind of box that as I go. This times this would end up being 20. And then we finish that up. 20 plus 6 would be 26. All right, let's look at a few more examples, and then I think we're going to be in pretty good shape. So how about we look at example number 3 next? So if we write down the expression, I'm just going to write down the expression down here. It's 16 minus 3, and what we're going to do is we're going to substitute in for b. We're substituting in what they're telling us that equals, which is 4. This means 3 times 4. 3 times 4, we're going to do that first. We're going to get 12. And if we do 16 minus 12, 16 minus 12, if you can't do it vertically, or I mean horizontally, then set it up vertically. And this minus this would be 4. So this minus this is 4, and the answer is 4. All right, let's go look at number 4. P squared plus 4, 4p equals 6. So let's erase all of this so we have some workspace here on the bottom. If we square that, if we substitute in the value for p, which is 6, and put an exponent, and now ask ourselves, what would this equal? Remember, that's not equal to 12. It's 6 is a factor twice, or 6 times 6, which is 36. And then add this 36 plus 4, and end up with your final answer, which would be 40. Now, in your workspace, you would also want to show that. And I want to just remind folks that you should have that triangular look to your work whenever you have multiple operations going on in a problem. All right, so let's see. Why don't we just do a few more from here? I think we'll be in good shape if we just do number 10. So if we do number 10, I'm going to rewrite that, because remember, step 1 is always good to just rewrite the expression. So I'm just going to put the written version of that. So that's 2 times k squared minus 2. There's the expression. Now we have to substitute in the value 6 for k. So we rewrite everything, even though we don't like it. And instead of putting a k, now we're going to substitute in the 6 for that. but don't forget about the exponent. And then we're subtracting 2. All right, next, we have a bunch of operations here. We have multiply, we have exponent, and we have subtract. So remember, we have to do the stuff in the parentheses first. And if you happen to have 2 operations within the parentheses, which we do, we have squaring in our exponents, and we have subtraction. So we're going to do the squaring first. We're going to do this first, right here. Now, when we do that, we get 36. So that's 2 times 36 minus 2. All right, so we still have parentheses to deal with, and we know that because there's still an operation contained within the parentheses. Subtract these 2 numbers and get 34. Bring down your times 2, and then we would finish up. Now, this is not mental math for most folks, so you don't just stare at it and try to figure it out. You do the algorithm off to the side. And here we get 4 times 2 would be 8. These 2 are 6. 3 times 2 is 6. So we get 68. Notice that triangular look to our work. So 68 is the answer for number 10. All right, so I think we should be in pretty good shape. I might make another video that might help you with more fractions and decimals, but you're going to go ahead and give the homework a try, and hopefully we'll be successful with that.